Hi, welcome to CMS. We'll continue now in the quantity surveying for the horizontal structure element, which is the slabs, then special type of the slabs, which is the ribs or the Hordy slabs. We'll start now with the normal slabs. We'll go for the slabs till mezzanine, as we mentioned before, that we consider here, or CMS considering that all the slabs below the typical floors have the same types and the same shape. If not, we'll see also how to be calculated. For the sheets of the slabs, we will find the description: slabs till mezzanine or podium level, as we agreed now, or as we mentioned in our project. We have two floors, which is the ground floor and mezzanine floor, as per the description. Ground floor and mezzanine floor. So all the data which will be entered here, it will be multiplied by 2, which is the number of the floors. If in your project the slab, till mezzanine or podium don't have the same shape or same dimension or same thickness or same reinforcement, you shall put here number 1 and do the required changes here in these tables. You can separate for each type, or for each you have to insert each floor separately. In our case, we have the same as mentioned in our drawing: ground floor and first floor, which is the ground floor and mezzanine in our case have the same shape. It's shared in one sheet only. In our slab, we have this shape of slabs. Here is mentioned the thickness of the slab and the reinforced mesh. We find here the thickness of the slab is 26 centimeters. We have the mesh top and bottom. We have the mesh, which means both direction, long span and short span. When you find mesh, that means it is in both direction. Otherwise, it will not be mentioned as a mesh. It will be mentioned as a long span separately and short span separately. In our project, we have a mesh that means in both direction, diameter of 12, each 15 centimeter center to center. As we mentioned before, CMS know about the how many rebar per meter. Where is this? This will be top and bottom reinforced. How this will be entered? Have first to put the dimension for the slabs. We'll take all the dimension of the slab, entering in CMS by length and width. In our case, we have only one type of slab with one thickness, so that means we need to enter the area of these slabs, which we can enter by the using order of area in the AutoCAD. Could the slab in our project have the same thickness and same mesh for all the area, we can take the full area one time and put it in CMS. But because we have voids in the center and also maybe some beams in the center, in case of some beams in there inside the slab, better we need to divide the slabs for proper areas. For some areas can be avoid the voids inside the slab. These voids like the staircase, the lift pit, any shafts for the building. So the best way to separate the area is using the polyline in the AutoCAD. Because we have an arches, this arch have a full length, so it's better to divide it by segments, or to just make some separation to stop the polyline on it, as we will do now. We will avoid the beams, because the beams area we already took before in the beams calculation, so don't need to repeat it again. You can take like this. And for the arch, as we mentioned now, that we divided in segments like this to take a proper areas. Of course, before starting any work on AutoCAD, you have to confirm that the AutoCAD is on scale. Before taking any dimension by AutoCAD, you have to confirm that the AutoCAD is drawn on scale. Then now we have this area. To know the area, just click on the polyline and write and order list LI. You will find here the area which you require, 132.5 square meters. That's for this area only. We'll continue also the same for the other side, polyline, and go through the areas corner by corner. That's one of the ways to calculate the area or to enter the area. If you can divide the slab for some ordered dimensions, you can divide it and take the dimension for each part separately, no problem, you can do it. Feel free to choose the method of calculating the area. As we said, our aim to avoid the opening, and by the same way you will do the other part. Feel free to use your method to calculate the area, either by the polyline, or you can separate the slabs for an ordered dimension and you can take this dimension directly on the CMS. You can put length and width. At the end you will have an area for the slab. You can enter in CMS only by length and width, because as we see here in the CMS sheet for the slabs, you will find the type and the floor. You can mention for the name of the slab here, and I mention also for the specified floor for each slab, the number of this slab, how many it will be, how many times it will be repeated, length of the slab, and the width and thickness. That means you have to enter the slab by length and width only. If our slab with 350 square meter, easily you can put it in 2 dimension, which is the common 2 dimension in the drawing. If we have here the common dimension is 15.4, so we can enter here the width is 15.4, and the length will provide by dividing the total area which we provided by the width which is 15.4 to get the length of the slab, and we'll put the thickness of the slab as it's mentioned in the drawing. That's the way to entering the dimension of the slabs. Any other types of the slab, if you have another type of a slab, this will consider this as an S1 or the flat slab. You will write only the description here. If you consider this like a flat slab, that's for your easy reference, and when you come back to check your dimension or you need to make any other modification. We have here in our project another extra bottom rebar and extra top rebar. It's mentioned in the drawing. How we will treat with this? Remember the same method which we used in the foundation, especially in the raft foundation. We will use the same. We'll start with the bottom. We have an extra rebar with dimension of 5 meters and repeated for 6.9 meter. This bar of repeated 6.9 meter in one direction in the bottom. What is this type? It's 16 milli and repeated each 15 cents in one direction. That means we can mention here as an extra bottom 1 repeated 1 time. The length is 5 meters for 6.9 meter as it is mentioned, and the depth of course is 0 because we don't have extra concrete there, we have only extra rebar with the reinforcement of 16 milli repeated for 6.7 time in the bottom rebar only in one direction. So we'll write in one direction only the reinforcement detail. It is only in the 5 meter. You can also ensure about the length of the rebar, which is 5 meter here. Okay, so we have one direction, so that means we'll fill only this cell. We don't have another direction. We don't have bottom if we are talking about this only. Actually, it is repeated here 2 times because we have the same here and there, so you can consider this as a repeated 2 times. We have also some rebar around the opening. It is 3 pieces of 16 milli top and bottom by this dimension. You will calculate also the length. It's 2.6 meters and here 4.15. You can consider it all together is 6.75, so you can enter here 6.75. We have only 3 pieces, so it is not an issue to make it as a 1 meter, and we'll put in this 1 meter a 3 pieces. It is 3 16 milli top and bottom. For the extra top, we'll do also the same as we have here. Extra top 1, 2, and those. We'll take it also one by one. Let's take one as an example. We'll mention as a reference extra top A we have here. That's the rebar. In the top we have one dimension with 16 milli each 10 centimeter, another dimension 25 milli each 10 centimeter. The length is 4 meter. That means this is 4 meter and this 4 meter. If there is different lengths, it will be mentioned here. But anyhow, we have here 4 meter by 4 meter. It will be entered on these cells like this, also without any thickness. Okay, then we will go for the rebar. You have here 25 milli each 10 centimeter, that means 10 per meter, and 16 milli in other direction each 10 centimeter, that means 10 16 10 per meter, 16 diameter. We will put here in the bottom. By the way, if you put it in the top or bottom, it will not make any difference. At the end it will be calculated the same, but here we will put it in top as a reference also for us. We'll make it 10 25 milli and 10 16 milli. Another rebar, we'll find here 2 meter for one direction and multiplied in 2 meter direction, so we have 2 meter by 2 meter, but we have also one direction in the top. We'll put it here because it is 20 centimeters, so we have only 5 pieces per meter for diameter 16 milli, and so on. We'll do the same for all extra reinforcement for this slab, and as we said before, it will be multiplied by 2 because we have 2 slabs have the same shape, which is for the ground floor and first floor or mezzanine floor, as it is mentioned in the CMS. So at the end, CMS will give you the calculation and the output for the rebar for each diameter, the total rebar required for these slabs, the concrete which is required for these 2 slabs, and the ratio between the rebar and the concrete, which is also reasonable to us, and also the shutters for the slabs per square meters, which will be required for the cost estimation, and which will be required also to be mentioned in the BOQ for your pricing and budgeting, and will be mentioned in the material which you have to provide. You can go through this sheet by using these buttons as we mentioned before for saving your time. Okay, that's the type of the slab which is a flat slab. There is other types of slabs, not only the ribs, as we'll speak about it later. No, some of the nearest type of the slab, which is a solid, normal solid slab, which you will find in too much project. The same way which we use it in the flat slab, you will use it in the solid slab. For solid slabs which have internal beams and slabs with different thickness, you will use it the same way. If you have a slab divided by some beams, you will take the beams separately in the beams sheets, and the slabs will take each type of slab separately, put the reinforcement which is there, bottom and top, and also if any extra, and put the same way which we enter the flat slab in CMS. Okay, now what about the case of using the rib slab, the Hordy slab, which we are using a Hordy block or a polystyrene or light block or any kind of filling inside the slabs. Actually, CMS give us a very good calculation on it. It's giving us proper calculation for the required numbers of ribs, required concrete, required number of blocks, and required reinforcement for the full slabs. And this will be explained in the next video.